Space is full of things that can kill you. Exploding stars, gamma-ray bursts, rogue planets drifting silently through the dark. But none of those are truly disturbing, because they still follow the rules. Black holes are different. They are the places where the rules begin to fail, where gravity becomes so powerful that even light cannot escape, where time bends, matter collapses, and the equations scientists trust everywhere else suddenly stop agreeing with each other. Imagine floating near one right now. No sound, no light, just a perfectly black circle where the stars should be. You drift closer. At first, nothing happens. Then the universe begins to bend. And the deeper you fall, the stranger reality becomes. Because when scientists started studying black holes, they did not just discover how dangerous they were. They discovered theories so unsettling that some physicists wish they were wrong. These are the 10 scariest black hole theories ever proposed. Number 10. Quantum immortality. This idea comes from the many worlds interpretation of quantum mechanics. According to this theory, reality does not follow a single timeline. Every quantum event splits the universe into multiple branches where different outcomes occur. In one branch, you turn left. In another, you turn right. In one branch, a fatal accident happens. In another, it never does. All possibilities exist somewhere. Now imagine falling toward a black hole. In most versions of reality, that story ends quickly. You cross the event horizon, and gravity destroys you. But if the many worlds theory is correct, there may always be one branch where something extremely unlikely happens. A random particle interaction alters your path. A tiny fluctuation pushes you just enough to survive. Your consciousness might continue in that branch. From your perspective, you never experience death. To observers in other branches, you died. But your awareness keeps moving into the timeline where survival happened. It means consciousness might always find the version of reality where it continues. You would survive events that should have killed you, drifting into increasingly strange versions of existence where the impossible somehow keeps happening. You would not escape death. You would escape dying, and the universe around you would slowly become less and less normal. Number 9. The information paradox. Physics is built on a simple rule. Information cannot be destroyed. If you burn a book, the pages disappear, but the information about that book still exists in the heat, the smoke, and the particles drifting away. In theory, the universe keeps track of everything. Black holes appear to break that rule. When something crosses the event horizon, every detail about it disappears from the outside universe. And when black holes eventually evaporate through Hawking radiation, the radiation escaping seems random. Not a coded message, not a record of what fell inside, just noise. That means black holes might erase information completely. If that is true, something deeply unsettling follows. The universe may not remember everything that happens inside it. Stars, planets, maybe even entire civilizations could fall into black holes and be deleted so completely that the laws of physics themselves lose track of them. Not hidden, not stored, gone. Number 8. Spaghettification. The name sounds harmless. The reality is not. Your ship is drifting toward the black hole. At first, you feel nothing. Then gravity begins to pull unevenly on your body. The side closer to the black hole experiences stronger gravity than the side farther away. The difference grows rapidly as you fall. Your feet are pulled downward harder than your head. Your body stretches, then stretches further. You try to turn around, but the engines cannot overcome the pull. Bones begin to separate, muscles tear, every molecule in your body is dragged in the direction of the black hole. The distance between your head and your feet grows larger and larger. Not because you are moving, because gravity is pulling you apart. You would not fall into a black hole as a person. You would fall in as a thin strand of atoms stretched across miles of space. Astronomers call this spaghettification. Number 7. Frozen time. Black holes do something strange to time itself. Imagine watching someone fall toward a black hole from a safe distance. They approach the event horizon. But instead of crossing it, something impossible begins to happen. They slow down, then slow down more. Their movements stretch longer and longer. Eventually, they appear almost frozen at the edge of the black hole. Their light becomes dimmer and redder as time stretches toward infinity. From your perspective, they never actually cross the horizon. They simply fade, becoming a ghost hanging at the border of the black hole forever. But from their perspective, nothing unusual happens at first. Their clock keeps ticking. Their thoughts continue. Two observers watching the same event experience two completely different realities. One sees a person falling inward. The other sees someone trapped forever at the edge of time. Black holes do not just trap matter, they trap moments. Number 6. Hawking radiation. For decades, scientists believed black holes were permanent. Once formed, they would remain forever. Then physicist Stephen Hawking discovered something surprising. Quantum effects near the event horizon cause black holes to slowly leak energy. Tiny particle pairs appear near the boundary. One falls into the black hole, the other escapes. Over extremely long periods of time, this causes the black hole to lose mass. Very slowly, it shrinks. A black hole the size of our sun would take far longer than the age of the universe to evaporate, but eventually it would disappear, which means black holes are not eternal prisons. They are cosmic shredders that slowly dissolve, and when they finally vanish, everything they consumed may vanish with them. Number 5. Firewalls. Einstein's theory predicted that crossing the event horizon of a very large black hole might not feel dramatic at first. Gravity would be extreme, but the boundary itself might not instantly destroy you. Some physicists now think that assumption may be wrong. To solve the information paradox, researchers proposed a disturbing idea. The event horizon might not be smooth. Instead, it could be a violent barrier of energy, a firewall. Anything touching it would be instantly incinerated into radiation, not crushed later, not stretched deeper inside, destroyed the moment it reaches the boundary. If that theory is correct, the edge of a black hole is not just a point of no return. It is an execution line built into space itself. Number 4. Wormholes. Some solutions to Einstein's equations allow tunnels through space-time. These tunnels are called wormholes, and in certain extreme models, black holes might contain them. Instead of being dead ends, they could be bridges connecting distant parts of the universe, or even entirely different universes. The problem is stability. Most wormhole models collapse instantly. The gravitational forces would destroy anything attempting to travel through them. But the disturbing possibility remains. Black holes might not just be objects. They might be cracks in the structure of reality. Places where the map of the universe folds in ways our minds were never meant to understand. Number 3. Baby universes. Some physicists believe black holes might create entirely new universes. Inside the collapsing core, space-time could pinch off and begin expanding again on the other side. To us, it looks like matter disappearing into darkness. But beyond that collapse, a new cosmos might be forming. A new universe with its own stars, galaxies, and perhaps even life. If that idea is correct, every black hole in our universe could be creating another universe beyond our reach. And one unsettling thought follows immediately. Our own universe may have started this way. The Big Bang itself could have been the inside of a black hole in some larger parent universe. Everything we have ever known might exist inside the aftermath of someone else's collapse. Number 2. Black hole natural selection. This theory takes the baby universe idea even further. Physicist Lee Smolin proposed that universes capable of producing many black holes might generate more offspring universes. Those new universes inherit slightly different physical laws. Over time, universes that produce more black holes become more common. In that picture, the laws of physics were not chosen to allow life. They were selected because they produce collapsing stars. Black holes become the reproductive system of the cosmos. Stars form, stars die, galaxies evolve, civilizations rise and disappear. But the real engine of cosmic evolution may simply be the creation of more black holes. Life is not the point. We are just a side effect. And number 1. Black holes reveal that reality is incomplete. Physics today rests on two extraordinary theories. General relativity explains gravity and the large structure of space-time. Quantum mechanics explains the behavior of particles at the smallest scales. Both theories work incredibly well, but inside black holes, they break. Relativity predicts singularities. Quantum mechanics says information cannot disappear. Both cannot be correct at the same time. Somewhere deep inside black holes lies a deeper theory of reality that scientists have not yet discovered. Black holes are the places where our understanding collapses. They do not just threaten your body, they threaten your explanations. They sit in the darkness like tears in the operating system of the universe, swallowing matter, swallowing light, and reminding us that the laws of physics we trust may only be temporary approximations of something far stranger. Because the more scientists study black holes, the more one disturbing possibility begins to appear. Black holes may not be holes at all. They may be cracks in reality itself. And the deeper we look into them, the more it feels like the universe is hiding something just beyond our understanding.